you recognize the person you see on your screen? Yes, he is the great Thomas Edison. Do you know what he is known for? In 1879, he invented the first practical, long-lasting electric light bulb. And since then, our homes are bright even after sunset. You must be aware of the fact that lights in our homes work on electricity. However, they're not the only ones that use electricity. Our televisions, air conditioners, water heaters, fans, and so on also need electricity to function. Laser light or even small flashlights also work on electricity. Imagine a life without electricity in the world today. The discovery of electricity has helped to start a new revolution in the history of humankind. But let's just keep aside all the rhetoric talks and try to understand the real thing. I haven't really told you what the term electricity means. Well, there are basically two forms of electricity. One is static electricity and the other is dynamic electricity. For now, we are only interested in dynamic electricity. From the name itself, we can say that it implies moving electricity, or more precisely, moving electric charges. Now the next question you have will be, what are electric charges? The concept of electric charges is very important in physics and it cannot be explained in a video or two. But I will still try to give you a short and to-the-point explanation of this concept. So let's begin. There are two types of electric charges. Positive, denoted by the plus sign, and negative, denoted by the minus sign. Think of magnets for a moment. We know that two like poles, that is, two north or two south poles of magnets, repel each other. And unlike poles attract each other. Similarly, like charges, that is, two positive or two negative ones, repel each other, and unlike charges, that is, a positive and a negative one, attract each other. But what exactly is charged? Or in other words, who actually carries these charges? Well, these charges are carried by tiny particles with incredibly small mass. They are called subatomic particles. The positive charges are carried by particles called protons, while negative ones are carried by particles called electrons. There are billions and trillions of protons and electrons present in any object around us. In some objects like metals, electrons can move randomly. While in non-metals, their position is kind of fixed and hence they cannot move freely. Now, any appliance in our house, for example a tube light, works because the negatively charged electrons are moving in the wire in one direction. This unidirectional motion of electrons in a wire is also called electric current. These wires are made of metal, usually copper or aluminium, and you can understand why. But why are the charges in a wire moving in one direction? Or what makes the charges move in the wire? The charges move in one direction in the wires because of the energy supplied to them by the transformers. So the transformer supplies energy, the charges move in a wire, which in turn makes our appliances work. A flashlight also works in the same way. But here the energy is supplied by the two electric batteries. So to sum it all up, dynamic electricity is flow of electric charges through conductors like, say, a copper wire. Generally, when we talk about electricity or electric current, we mean dynamic electricity. Hence, we simply say that electricity is nothing but the flow of electric charges through a conductor. In the next video, we will learn how to light up a small torch bulb using a single electric cell. So see you there.